Hello, I'm Dr. Harper. This video is in project management. It's the homework tutorial for PMBOK-2, Schedule, Cost, Quality, Risk, Procurement, Knowledge Management. So let's bring up the homework. So I'll only work the quantitative problems and I'll work them through, and we will have the different resources in my website, MD Harper Project Management, in the videos. But I'll just work through these particular problems. You can see how to work them. Question 10. In a project, length has been identified as a quality characteristic to be monitored by a process control chart. The quality characteristic is assumed to be normally distributed. Using the measured data from an experiment under control, construct a simple process control chart. What is the lower control limit, the center line, and the upper control limit of the control chart? And so down here, we have the length in meters, and so let's copy this. And let's bring up Excel. And let's come down our ways and let's paste it in. And then let's in full screen increase this. And so to work this, we want the mean. We're going to want the standard deviation. And we want the standard deviation of the mean. And then for the say upper control limit, the center line, and the lower control limit over here, this is going to be the mean plus 3 standard deviations of the mean. This is the center line. And this will be the mean minus 3 standard deviations of the mean. So this is what we're after. So first of all, let's get the values here. Equals the mean is going to be the average function. A-V-E-R-A-G-E. You need to spell it correctly. If you spell it correctly, then it knows it's a function. Okay, then we highlight all of these. Boom, there's going to be the mean, the standard deviation equals standard deviation, equals standard deviation dot the population standard deviation. And so, and usually in statistical quality control, the population, not the sample standard deviation, the population standard deviation is used. So we highlight all these, return, and so the standard deviation of the mean simply equals the standard deviation divided by the square root of the sample size, 12. And now we have the mean plus 3 times the standard deviations of the mean. We have the center line. We have the mean minus 3 standard deviations of the mean. And there's your answer. And I'll let you pick out the answer. Okay. Now, question 11. A project received, and again, this is in project management MCDM selection. Vendor selection. A project received proposals from a response to an RFP and is in the decision process of selecting one vendor. The project selection committee agreed on the criteria and the weights of each criteria, and there they are. Then, after detailed discussion of considerable information on each proposal, each of these proposals, they looked at a lot of information. The project selection committee assigned a measure to each proposal for each criteria on a scale from 1 to 100, where higher is better. And so all of these have been assigned by the selection committee. Which proposal has the greatest unbiased weighted score? And so it's not just a score, it's an unbiased weighted score based on the MCDM approach, multiple criteria decision model approach, using the collected information from the RFPs. So let's bring this in. Let's bring these numbers in here, and there they are. Control C. Let's bring Excel back, and let's bring this down here, and let's put it right here. Control V, and there it is. Okay. And rather than going step by step, I'll just solve this thing. You take the sum of the measures right here, and that sum of the measures indicates the actual bias, the magnitude of the bias. So this will equal the weight divided by the sum, and that standardizes it. And then we have the score down here, which is the sum product of the actual weights here, F4 to fix those, comma, the actual measures. And so there we have an unbiased measure there. Let's copy this over. And now we want the max. And so if this equals the max of all of these, F4 to fix them, then we're going to say max. Otherwise, it's just a blank. I see here I made a mistake. That should be a closed parenthesis. Oh man. And then the if statement went away. Equals if, let's do this again, if this equals the max of all of these numbers. I'm going too fast. There we go. F4. Then I did it again. Close parenthesis. Okay, comma. Then I want to print max. Otherwise, just a blank. There, I finally did it. Okay, let's copy this over. Let's see which one pops up. Okay, this one right here. This is probably, and I'll let you select your answer then. Okay. Question number 12. Again, here's information that supports this. I'll just work it. This is an EVA. A company is preparing a report of the earned value analysis for the end of March based on the cost baseline. There's a cost baseline at the end of March. So in the end of March, the third right here. So let's take this information right here and Control C. Let's bring Excel back, come down here a ways in here, and let's Control V this, and there they are. But we also want this information. Okay. Well, actually, let's come back to that in a minute. These is our planned values. What we want to do here equals the sum of every row, and this is how we do it. The sum of every row. Copy that down. And the sum of every column. And we'll copy that across. There's a sum of every column. That's good. And then the sum of everything. Sum of all of them. That's the sum of all the planned values. And it's a $25,000 project. Okay. Now, the EVA is at the end of March. So let's put this a thick border. And let's go ahead and see if we can shade this a little bit. Just to make sure that we are careful to know that this is where the actual EVA is. Okay, and so now we bring up these percentages. 100%, 100%, 65%. So let's put these in here. This is 100, 100, and 65, and there they are. The rest are 0. Okay, now these are percentages, and so essentially we want the earned value here, which will equal the planned value times the percentage, which is this, divided by 100 to make it a percentage. And then we copy this down, boom, boom, and that's 100%, that's 65%, and then we sum these. Bring all the way down here, and that's going to be this. And this, the sum of the EVA planned values are going to be these three, which is there. There's our EV, there's our PV. And so come down here. We're going to have the earned value of the EVA, the actual cost of the EVA, and the planned value of the EVA. Well, we have those. This is going to equal this number. This is going to equal this number. Now, what's the actual cost? That should be given in here somewhere. Oh, here it is. At the end of March, the actual cost is reported to be $8,100. Okay, there it is. So we'll bring this up here and we'll say 8100, $8,100. And so that's the information we need to generate our EVA. Now, down here, the answers is going to be is on budget, under budget, over budget, on budget. Is it on budget, over, under, ahead of schedule, behind schedule? What's the projected time of completion, expected cost of completion, that kind of thing. So what we need to do here, we can get all of these. Let's take the indexes. Let's get the a cost performance index and schedule performance index. Okay. So this will equal the EV divided by the cost, and this will equal EV divided by the planned value. Okay. And then let's do the estimates at completion. Estimates at completion. Okay, the estimated cost of completion, that's going to equal the 25,000 divided by this. And this is going to equal the 1, 2, 3, 4, 5, 6. This is equal the time of completion, which is 6, divided by the schedule performance index. And so they're the values. And so from this, we can tell this is above 1. Remember, below 1 is bad, above 1 is good. And here's the estimates of completion. And then you say, okay, well, a good cost, which it is, means you're under budget. Okay, means you have earned what you have spent less than what you've earned. The schedule performance index means you're ahead of schedule. Okay, under budget, ahead of schedule. And so there's where these answers come in. And you can see here where your answers are over here. Okay, and I'll let you pick out those answers from these right here. And that should be enough. Okay, and so let's come back here, do the next one. Question 13. After the budget information for the annual tribute dinner was collected and reported as normal cost, column 1, each person was asked to submit an optimistic cost estimate, column 2, and a pessimistic cost estimate, column 3, to address the cost risk experienced from past projects. Assuming the expected cost of each task is determined by the expression optimistic, so it's a weighted mean of optimistic, pessimistic plus 4 times the normal. What is the total estimated expense of the project based on the expected cost? Oh, okay. So let's just take these again right here. Control C. Let's bring back Excel and come down to here, right here, and then Control V. Let's paste these in. And remember, this is the normal cost. Remember, the normal cost is the first column. So this will have a weight of 4. This will have a weight of 1 and a 1. Okay, so this equals 4 times the normal plus this here, and then divided by 6. And then you copy this down, all the way down, and then all that's being asked here is to sum this. It's to sum all of these. And this is just going through the experience of actually getting a weighted mean, an estimate of the weighted mean, where the normal cost is weighted heavier than the optimistic and pessimistic, and it's 4 to 1 to 1. So I'll let you pick out those answers to that one. Finally, 5 projects are being evaluated using earned value analysis according to the EVA values down here, these EVA values. So there are 5 different projects, each has their own EVA values. Which project possesses the best overall performance, assuming higher values are better? Okay. Well, let's take these. I think let's go ahead. I think all we need is these, really. And let's Control C these. And let's come over here. let's bring Excel back, come down here, and post these in here. There they are. So all we need is the cost performance index and the schedule performance index. And so that's simply, whoops, I can bring these down into the headers. Okay, is equals the EV divided by actual cost, and schedule is the EV divided by the planned value of the EV, and that's all it is. Okay, and so all you do here is say which one of these higher is better. Well, that's better than that, and that's better than that, and so both of these are low, both of these are high, but then higher is better. Which one of these is the highest? We can see here's this one right here, and I'll let you answer that. Okay, I'll let you answer the question on that one. Okay, now number 15. Again, we have some PMBOK 5th edition for, anyway, here's the supports. But let's do this. Match the activity on Node Network with the correct project definition. Oh, okay. Well, you know, probably the best way to do this is just take this, Control C, and just bring this into Excel down here, and there it is. Let's just say Control V, and there it is. And there's 6 activities, 1, 2, 3, 4, 5, 6. Okay, let's just see what is the predecessor activities. Okay, well, the predecessor of 1 is nothing, so I'll just say nothing. 2, let's bring this up a little bit. 2 has a predecessor of 1. 3 has a predecessor of 1. 4 has a predecessor of 1 and 2. You see here, these are the predecessor relationships, 1 and 2. 1 and 2. 5 here has a predecessor of 3. And then 6 here has a predecessor of this line here is 4, this line here is 3, 3, and 4. Okay, and so this right here, here's the activities, there's the activities, there's the predecessors, and this right here will help answer the question down here, what is the actual definition? Which one has the correct definition? And I'll let you do that. I'll let you pick the one that matches this. Okay, question 16. You have come to a planning meeting where the network is being discussed of an upcoming project. The network is given below with a duration in weeks. Okay, below the activity name. The activity name is the letter. Okay, and what is the time of completion of the project in weeks? I give it a lot of answers here. Where's the time of completion? Okay, now what we're doing is analyzing this network with the activity on node. Control C. Let's bring this over here. Let's do this again. Come down here. Right here, let's paste this. Let's bring this down a little bit so we can see it. That's kind of good. Okay, now we have A, B, C, D, E, F, G, H, I. Those are the ones we have. Okay. Now there's different ways of doing this. We're going to have the predecessor relationships. Let's go ahead and do that again like we did before. A has nothing. There's no predecessors. That's good. Okay. Now B here is A. Oops. There we go. C, actually B has A, C has A, D has A. So B, C, and D are all A. E has B. Put a B there. F has B, C, and D. So F has B, C, and D. G has E and F. See, G here has E and F. E, F. H is just F. I here has D and F. That's interesting. D and F. DF. Okay, and there's the predecessors. Now the durations. T. Well, 2 here, A is 2. B is 4, 3, 5. 4, 3, 5. E and F is 2 and 4. 2, 4. And then GHI is 5, 6, and 3. 5, 6, and 3. Okay, and I think the easiest way to get the time of completion is to get the early start and then the early finish. Okay, and then the max of the early finish will be the time of completion. Okay, we start here. The early start is 0. The early finish here will simply be the early start plus the durations, and there they are. Copy these down. Okay, now then let's bring these activities over here so we can see them easier. Here's your predecessors. So the early start here is A. Well, A is going to be 2. A is 2. Equal 2, equal 2, equal 2. Then B. B is equal 6. BCD. That equals a max of BCD. BCD is B, C, D is those, max of those. Max of ENF equals max of ENF. ENF is right here. There's ENF. Then activity, this activity, H is going to be F. F is right there. Okay, and then max of DNF. Max of DNF, there's D, comma, and there's F. And there it is again. And we're done. Equals a max of all of these. Whoops. Well, that's not right. Sorry. It's not that one. It's early finish. Equal the max of the early finishes will be the time of completion. I take the max of all of these, and there it is. And we'll box that, bold that. That's the answer. I'll let you pick it out. Okay. 17. Okay, what is the time of completion and the critical path of the following project? Okay, here's a problem. We have to work it all the way through. Okay, so let's Control C this. we want the critical path, time of completion. So we need to work this all the way through. Let's bring this down here. Come to C here. Okay, this is our activity. This is the predecessor activity. And this is the duration. Let's start with the early start and early finish, just like we did before. Okay. So the early start here is going to be for the predecessors of nothing here. Actually, let's bring the activity over like we did, just like we did before, to here. So the early start of no predecessors is 0, 0, 0. This is activity 2. So well, actually, this is going to equal the early start plus the duration. Copy these down all the way. Okay, now we need to fill in the early starts. Make this a little larger so we can kind of see it. That's a little better. Okay, here we go. Predecessor is 2. So this equals 2, which is 17, the early finish of 2. This is the max of 1 and 4. Equal max of 1 and 4. There's 1, comma, there's 4. There's 4 right there. Okay, max of 2 and 3 equals max of 2 and 3 is 17 and 15. And there it is. Max of 3 and 5 equal max of 3 is that, comma, 5 is 44. Okay, this is 6 equals 6. Max of 4 and 6 equals max of 4 and 6. There's 4, comma, and there's 6. Okay, here's 8 and 8. Here's equals 8, equals 8. Max of 7 and 10 equals max of 7 and 10. There's 7, comma, there's 10. Good. This equals 6. The 6 is 27. Max of 11 and 12. Max of 11 and 12 is right here. Max of 10 and 13. There's 10, comma, there's 13. And we are done. Okay. The max of the early finishes will be the time of completion of this project, and there it is. So now we know the time of completion. There it is. TOC. TOC. But we don't know the critical path, to get the critical path, we need the successor activities. So let's bring these over here. Just copy these over here. And now let's get the successor activities. Okay, here we go. These are the predecessors of 1, 2, and 3. So 1, 2, and 3 will be the successors of nothing. 4 is the successors of 2. So we come up to 2 here and we say 4. 1 and 4 is 5. 1 is 5. 4 is 5. 6 is the predecessor of 2 and 3. So here's 2 here. And let's see, where was it? 5. Okay, let's back up here. Where was I? Here's, okay, 5. 6 now is a predecessor of 2 and 3. So 6 is for 2 and it's for 3. Okay. Now 7. 7 is a predecessor or successor of 3 and 5. So we need a 7 here and a 7, 4, 5. There we go. 8 is the successor of 6. So go to 6 and we say 8. 9 goes at 4 and 6, so 4 is 9. And 6 is 9. There it is. And then 8 here, 8 has successors of 10 and 11. Here's 8, it's 10 and 11. 12 is the successor of 7 and 10. So 7 is 12. 10 is 12. And then 13 is the successor of 6. Here goes to 6, put a 13. 14 is the successor of 11 and 12. So we place 14 here at 11 and 12. There it is. And finally, 15 is 10 to 13. 15 is 10, 15 there, and 15 here. And there's all the successors. So let's take these, let's box these in. So these are going to be our successors. There they are. Very, very good. Okay, now then, we don't need the predecessors anymore. We needed those to get the successors, and now we have them. Okay. But now, what we're going to be doing is getting the late start and late finish. Let's just move these over. There it is. Now we want the late start and late finish. And I'm going to have a late finish here and a late start here. Okay. Where start with late finish equals the time of, where there's no successors right here. So the late finish equals the time of completion, which is 90. If there's no successor here, so that's equal to 90. That's equal to 90. And once we have these, a late start will always equal the late finish minus the duration. And we copy this down, all the way down. There we go. So now, whoops, one more. That's dangerous. Make sure we get them all in. There they are. Okay. Now, as we come down here, now for these successors, we want the late finish of these activities. Okay. So what I'm going to do is go ahead and move these over a little bit. Move this over one and bring the activities over. So now we're looking at these activities, and there they are. Here we go. So now let's go through and do these. Let's move this over a little bit so it's in the middle. You can see it. Okay, now then. So activity 1 has a successor of 5, right? So this late finish here is going to equal, let's bring this up here. Okay, so now what we're going to be doing, make sure I get all the answers right as I go down, put in the right format, and there we go. Okay, Now the late finish here is going to be the successor of 5. So that equals 5 is right here. This is 4 and 6. So that equals the min of 4 and 6. So 4 is here, comma, 6 is here. And there it is. This is the min of 6 and 7. 6 and 7 is right here. 6 and 7, 6 and 7. This is the min of 5 and 9. And here's 5, comma, here's 9, which is right here. Okay. This equals 7. There it is. Equals the min of 8, 9, and 13. So here's 8, 9, and 13. Okay. Equals 12. There it is. Equals 12. Whoops. Equals 12. There's 12. 12. This is 10 and 11 equals the min of 10 and 11 is right here. This equals the min of 12 and 15 of 12, which is right here, comma 15, which is down here. Okay. This equals 14 equals 14 equals 15. Okay. And so therefore, just to make sure, let's just highlight these. This should be 5. It is. There should be 4 and 6. There should be 6 and 7. There should be 5 and 9. There should be 7. This should be 8, 9, and 13. This should be 12. This should be 10, 11. This should be the time of completion. This should be 12 and 15. This should be 14, 14, and 15. And then time of completion, time of completion. I think we got it. Okay, very good. Now right in here we can say slack. Oops. Okay, and that could be either the late start minus the early start, late finish minus the early finish. Let's see. Let's do the late finish minus the early finish. And let's copy this down, and there's our slack all the way down to there. And there we go. And so let's add a column here. Well, let's not add, let's move this over. And let's say critical path. See critical path. Okay, if the slack equals 0, then this is a yes. Oops. Otherwise, blank. In other words, if the slack is 0, it's a critical path. Otherwise, it's not. So right there, our critical path are these activities. And let's just move this over again. Now that we've done this, we can move this over again and move our activities over. And so now we can see where our critical path, whoops, where our critical path is. Okay, if I can get it right. There it is. Okay, now then we see that it's activity 2, 6, 8, 10, 12, and 14. Time of completion is 90. I'll let you take that out and answer the question up here. I'll let you answer the question. Okay, we're getting there. Okay, let's see here. Question 18. 5 projects are part of a program where risk of project delays is being evaluated as one significant criterion. Select the project with the greatest probability of exceeding 530 days. That is TOC greater than 530. Okay, so let's bring this in. let's bring all of this in. Control C, bring Excel back. And move this over, come down here, and put it right here. And there it is. Okay. Now remember, it's 5:30. Okay, so let's put 5:30 in here. Whoops, put T, 5:30. Okay. And then down here, let's do the Z. And then let's do the probability greater than 5:30. Right there. So let's do that. Okay, now this is going to equal 5:30 minus the mean of that project divided by the square root of the variance. And there it is. Okay. And having done that, then the probability then is the normal standard distribution of whatever Z is. And Z is going to be that. And there's a probability. Okay. Now we want 1 minus that, because that's the probability greater than that. Okay. In other words, this is what I did. 1 minus the probability of the Z. So this normal distribution is less than. So 1 minus that would be greater than. Okay. So this is equal this. And this can be copied over to here. And then come down here. And then we zip, zip, zip. And there it is. And the question is, what is the max probability? And so here you can say equal. If that probability equals the max of all the probabilities, F4 of all of them, okay, comma, then say max. Otherwise, just leave it blank. Max, let me say a question mark. There we go. So this right here, and let's come over here. Which one is it? Which one is it? Oh, I guess it's this last one there. So that's the answer to that one. I'll let you answer that one. Okay. Now then, this 19 and 20, the Golden Project, I'll do this in a different video. This is all I have for PMBOK-2 homework tutorial. I hope this helps. Between the now and the next time I see you, everyone, take care.